Hello everyone, I'm Frank, and welcome to Frank Puzzles, and this is today's challenging level puzzle. And it's called Numbered Products Sandwich by Rocky Rower. And here are the rules. Normal Sudoku rules apply, which means fill every row, column, and box with the digits 1 through 9 without repeats. Clues outside the grid must be deduced. They are simultaneously sandwich clues and numbered product clues. Okay, that's why, hence the name Numbered Products Sandwich. A question mark could represent any 1 or 2-digit number. Square numbers are 1, 4, 9, 16, 25, 36, etc. And prime numbers are 2, 3, 5, 7, 11, 13, etc. So the normal idea of what a squared number is and what a prime is. A sandwich clue is the sum of the digits in the cells between the 1 and 9 in that row or column. So for example, if we say we had a 1 here and a 9 here, and this was 4, 3, and 6, the sandwich clue for this column would be 13, because it's the sum of the digits in between the 1 and the 9 in this column. So therefore, it would be 4 plus 3 plus 6, which adds up to 13. And that's how sandwich clues work. And remember, all clues that are outside the grid is a combination of a sandwich clue. It's both a sandwich clue and a numbered products clue. So it has to fulfill this sandwich clue rule. A numbered product clue is a product of x and y, where x is the digit in the cell next to the clue, and y is the digit in the x cell from direction of the clue. For example, the row, so let's just use a random row. Say this was 3, 1, 4, 5, 9, 2, 6, 8, and 7. It looks kind of like pi, actually. 3.141592. Yeah, probably is. Derived from that. So the number product clue would be the product of x, which is the digit in the cell next to the clue. So therefore, in this direction, it would be 3, times y, where y is the digit in the x cell from the direction of the clue. So this would be 3 times 4, which would be 12, right? Because 4 is in the third cell, which is x, right? So therefore, this would be 3 times 4 if you look at it this way. If you look at it this way, x would be 7 because it would be here, and the 7th digit would be 4. So therefore, the 7 would be multiplied by the 4, which would give you 28 as the numbered product clue. And remember, every clue that's outside the grid is basically both a sandwich clue and a numbered product clue. The question mark can be any 1 or 2-digit number, but it has to be the same for the sandwich clue and the numbered product clue, obviously. So for example, if this question mark were, say, 25, that would mean the sandwich clue part would mean there has to be 25. The digits between the 1 and the 9 have to sum up to 25. And then the numbered product clue would have to also multiply to 25. There would be problems with that, obviously, but that is how that works. And those are all the rules. I'm going to pause because I need to go to the bathroom. We'll just pause for a little bit, and we'll be right back. And I'm back. Apologies. I've been going to the bathroom more because I've been trying to drink more water. That's actually a good thing. I remember, everybody, try to stay hydrated. Hydration gives you a lot of benefits. Basically, probably health-wise. Just basically, it allows you to flush out more of your impurities in your system. It gives you ample water so that you can react to various things. Anyways, stay hydrated, people. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So we need to think more about what it means to have. Oh, okay. If you have a prime number, that means it's the product sum clue has to be between it and 1, right? Because it's prime, there's no other way to get a multiplication that adds up to that would multiply to a prime number except for the prime number itself times 1. So that means this prime number has to be 2, 3, 5, or 7, because those are the only prime numbers that are digits. And the 1 has to be in one of those slots. So it's either here, 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 or here as the 1, right? This is a square. But if this is 2, say this added up to 2. The problem is that you would have to have a 2 between the 1 and the 9 also. But that's not possible. So the problem is similar if you have a 3, right? If you have a 3, what digits sum up to 3 that would be in between the 1 and the 9? Well, it could only be 3 by itself because that's you can't have 2 with any other digit because 1 is not allowed to be in between. And 3 is already in the spot. So therefore, this can never be 2 or 3. This has to be 5 or 7. So the 1 is in one of those slots. And obviously, it can't have a 5 specifically in between the 1 and the 9. So it would have to have 5 and 9 between, sorry, it would have to have 2 and 3 between the 1 and the 9, but we don't know where that is. So it could be 1 here, this could be 2, 3, this could be 9, or this could be 2, 3, and this could be 9. Otherwise, the 1 is in the 7th spot. And again, your 7 could not be in between the 1 and the 9, but it could be 2, 5, or 3, 4. And it would have to go this way. So then this would be 9 if that's the case. So if this is 1, the 9 could be, so this obviously cannot be a sandwich part. So if this is 1, the 9 is either here or here. So it could be here with this being a sandwich and this being a sandwich with 2, 3 in between. Or if it's here, it has to be here as a sandwich. So this can never be a sandwich clue. Sorry, this cannot be a 1 or 9. So the end point of a sandwich. This could be, this cannot be, because it's either here with these 2, or it's here with this one. So this can never be the end point of a sandwich clue. So again, it's here with one of these 2, or it's here with here. So this is either 1, or it's in between the sandwich, which would make this 2, 5, or 3, 4. We don't know which. We don't know about these, though. There's no guarantee about the other ones. Okay. So this is prime. Square could be... If you try to have it as 1, that doesn't work, obviously. Because you can't have 1 times 1 anywhere in this row. If you have 4, you could have the 4 here and then the 1 here. You can't have the 1 by itself, because the sum in between would have to be a 4 also, right? So that doesn't work either. So if this is 4 and this is 1, the problem is the 4 cannot be in between the 1 and 9, and there's no 2 digits that add up to 4 that could be in between 1 and 9. So 4 doesn't work. 9 does not work because it has to be, well, actually 9 could work. No, 9 could not work because 9 would mean that the 1 has to be in the 1 spot. So this would be 9 times 1 to add up to 9. But then everything in between would add up to 35. So 9 is out. 25 is out for the same reason, except that, well, 25 is out for a slightly different reason. You can't have 25 and 5 in the same row, and that's the only way you can get to 25. So 25 is out. You can't have 36 in between as a sandwich clue. So 36 is out. Therefore, the square must be 16. So it must be 2 times 8. Well, if you had 8 here, that would mean this would have to be 2, but that's not possible. So therefore, you need 2 here, which means 8 has to be in the second position. So this is 16. In between the 1 and 9 must be 16 worth. We already have 10 outside, so that's 25 left. Interesting. This is odd in this way. So this digit must be 1, 3, 5, 7, or 9. In between has to be 16, right? So because in between has to be 16, outside has to be, what does it have to be? It has to be 35 minus 10 minus 16, which would be 26. So that would have to be 9. But these two don't add up to 9. Therefore, and you can't have 3 digits adding up to 9. That does not include 1 or 9 without a 2. So therefore, this must be a 1 or 9 because there's no other way for that to be a non-9. So therefore, this cannot this has to have 3 digits at least adding up to 1 or 9. And the remaining 2 have to add up to 9. So it's either 3, 6, or 4, 5 here. It cannot be 2, 7, cannot be 1, 8. It can't be 1, 3, and 5 because 1 has to be part of it. So therefore, this must be the other, the bread part of the sandwich. So in between, so this is odd, and it cannot be 1 because if it's 1, that would mean that then you'd have 1 times 1. But 1 cannot be a sandwich clue, so this can't be 1 in between. Therefore, it's supposed to be 9 times something. And it has to be 9 times 3, because everything else is too big. If you have, well, you could have 9 times, no, if it's 9 times 1, that doesn't work, because, again, it would be that 9 is the clue outside, but then 9 doesn't fill the sandwich because it's 35. And if you try to have a 5 here, or more, that would mean that the clue would, the product sum clue, the number product clue would be basically 45, but the sandwich can only be up to 35. So this must be a 3. That's 3 in the corner. We celebrate because we know kind of where the rest has to be. So this is 27 in between, which means outside has to be 8, right? 35 minus 8 is 27, which is what has to be in between. So this must be a 5 here because there's no other way to add to 8 with a 3. Therefore, this must be a 1. So this can't be a 1, which means this has to be 5. So this cannot be 4, 5. This becomes 3, 6. This is a 1, and this has to be 4 and 7, adding up to 16. So this is 5, which forces this to be a 1. So this is a 1. 9 cannot be here, so 9 has to be here. So this has to be 9, which makes this 2 and 3. This can't be 3, so this must be 2, which makes that a 3. So none of these can be the bread part of the sandwich clue. And this can't either. So one of these is a bread clue. One of these is a bread clue. This cannot be the 9, though, because if that were 9, the sandwich clue would be 0, but you can't have a number product clue be 0 at all, because there's no 0 in the digits. This has to be, what, 2, 4, 6, 7, 8. That adds up to 27. That's fine. This is a square, so this is 2. That's interesting. What does that make this? We don't know. Oh, wait. That's interesting. The sandwich part has to be the same for this column and this, yeah, for this column either way. So whatever this number is must equal to whatever this number times another number is. What could that be? It would have to be 2. Could it be 2 and 9 is the question. Okay, so what possibilities are there? 2 and 3 was 6 and 1, except that the problem is that you can't have a sandwich then work correctly, right? You'd have to have 6 and 1, but the 6 can't be in between. The 2 and the 3 can't, 2, 4 can't be in between either. So there's no sandwich that works there. You could have potentially 2, 4, and then 8, 1, but the problem is then 1 and 4 would both have to be here, which is not allowed. And it can't be 1, 8, obviously, because the 1 would have to be multiplied by itself. So that doesn't work either. 2 and 5 doesn't multiply together with any other digits, right? You would have to have 1 and 10 be the other digits, and that's not, 10 is not a digit. So 2 and 5 doesn't work. What about 2 and 6? That could work. Yeah, that could actually work. You could have 4 and 3, then, if that's the case. Ah, but this can't be 3 because we know 3 is here. So it cannot be 2 and 6, then. To have 4 and 3 multiplied together. So that doesn't work. 2 and 7 doesn't work because, again, you don't have any other factors that multiply to 14. 2 and 8 is 16, but then you would have to have 4 and 4. And that doesn't work because you can't have duplicates in the same column. So this must, and it can't be 2 and 8 because 8 is here. So this must be 2 and 9, which means the remaining ones have to be 6 and 3 to multiply together to get 18. So this is 6, this is 3, because it can't be 3 here. And what's in between the 1 and the 9 has to be 18. Well, it can't be here. So it's 18. We already have 8 outside because this can't be either. We already have 8 outside because of the 6 and the 2. So 18 plus 8 is 26. 35 minus 26 is 9. So we need an additional 2 at least, and those have to add up to 9. And I think that has to be 4 and 5 then, right? Because it can't be 2, 7, can't be 3, 6. Obviously can't be 1, 8 because 1 is part of, is the bread. So it has to be 4 and 5. This can't be 5 because of this 5, so this must be a 4, and this must be a 5. This has to be a 1, and the remaining digits have to be 7 and 8 to add up to 18. And that works. So these are gray. This is 5. This is 6. What is in between? What's the most that could be in between the 6 then? It would have to be 3 digits, which could be 4, 5, and 7. No, 5, 7, and 8 at most, which would be 20. Okay, so what are the possibilities here? This could be 1. It could be 2. It cannot be 4. If this is 4, then you have to have 24 in between the 1 and the 9. But then the 1 and 9 would have to be these two at best. And then you can't have 2 digits adding up to 24. So this is 1 or 2. If this is 1, that means this has to be a 9, and this has to be a 2, 4 in between, which does work. If this is a 2, that means it's 12, and then you have 1 and 9 in between. You would have to have 4 and 8. Well, it could be 5 and 7. Right, so if this is 1, this has to be 9, which forces this to be 2, 4. That works. It's because 6 times 1... Oh, we have, 6 times 3, that's fine. But if this is 9, if this is 2, 6 and 12, that would mean 1 and 9 would have to be, this would have to be 9, and this would have to be 1. Because this could not be, so in either case, this can't be part of the bread. So this would be 9, this would be 1. It could be 4 or 5 with 7 or 8, because it cannot be 3, 9, obviously, to add up to 12. So both of these work. Okay. What could this be? This could be 3, 4. It cannot be 5. It could be 6. Because 30 is possible to still be within the sandwich. So this could be 3, 4, or 6. And that's it. 35 times 7 is too large for the sandwich clue. Okay. This cannot be 2, because what can be in between the sandwich cannot be 2 times 1. This is obviously not a sandwich clue. Can't be 9. This can't be 8 because of this 8, so this must be 7, which makes this an 8. So this can't be 8. Don't know what this is. If this is 1, this becomes 9, and 2, 4 has to be in between. But where is the 5 in box 8? It can't be any of these, can't be any of these, and it can't be any of these. So that's not going to work. Therefore, this has to be a 2. So this is 2, which means 1 and 9 both have to be here. So this is 1, this is 9. Where is the 5? Again, in box 8. It has to be here. So this is 5, which makes that a 7. So this is not part of the bread. This is the bread. This is the bread. This is not part of the bread. So this is full, so none of these can be part of the bread. This can't be part of the bread because we already have a 1 and a 9 in the box. In the column, sorry, in the box we have a 9, and in the row we have a 1. So so the 9 has to be one of these two. This is 7 times something. We don't know what. You could have a 1 here. This could be 1. It cannot be 2. It could be 3, and it could be 4. 5 is not allowed because that's too big. So one of these is 9, which means none of these can be a 1 or a 9. Okay, so you could have 4. You cannot have 5 because outside of the sandwich is already 3 digits. Let's see. 1 is one of these two. 9 has to be one of these two. 1 is one of those two. Okay. The rest of this has to be what? 2, 3, 8, and 9. Obviously, 9 can't be these. 2 can't be here. These can't be 8. That's interesting. So 8 is one of those two. The remaining digits here are 4 and 8. The remaining digits here are 4, 6, 7, 8. We have a 2, 4, 4, 6, 7, 8 quintuplet in box 3, which eliminates 2, 4, 6, 7, 8 from the rest of the box. So this has to be 1 and 3. Well, where's the 2 in this box? It has to be one of these two cells, which means it cannot be in the rest of the column. So this can't be 2, and this can't be 2. We have a 4, 6, 7, 8 quadruplet in box 6, which eliminates 4, 6, 7, 8 from the rest of the box. So this has to be 2, 5, and 8. Sorry, not 2, 5, and 8. 2, 5, and 9. And obviously this can't be 9. So 9 is one of these two. The rest of this has to be 4, 6, 7, and 8. This can't be 4. We don't know about this. Can't be 4 or 8. So this is 6, 7. We have a 6, 7, 6, 7 pair in column 7, which eliminates 6 and 7 from the rest of the column. This can't be 7, so this must be 4, which makes this a 7. So 4 cannot be any more in these cells. This is a 4, which makes that not a 4, so that's an 8, which makes that 4. Again, this can't be 4. 2 is one of these. That's fine. This is 7. So whatever this digit is, it cannot be 1, 2. It could be 3, and it could be 4, right? Because it can be multiplied to 21 or 28. Cannot be 25. Actually, can't be 28 even, right? If this is 4, this could be 1, but then this would be 9. And we already have 9 outside of the sandwich. So that's 35 minus 9, which is 24. Sorry, yeah, 24 at most. So this has to be 21 in between. Which, I don't know if that works. It almost guarantees 1 has to be here, because if 1 is not here, this is never going to get 20. You need how many digits? Well, you have at minimum 5, 6, and 8 now, so it's 4 digits. So 4 digits in between, and therefore this must be a bread, so this is 1. This can no longer be the other endpoint of the bread because it has to be 9. You need 4 in between at least, so this must be the 9. And what's outside is 35 minus 21, which is 14. This is 9 already, so 14 minus 9 is 5. So this has to be 5. The remaining 3 digits are 4, 7, and 8. Oops. They're 4, 7, 8. 1 has to be here, because that's the only remaining place for the 1 in box 5. And 9 could be either of these two. We don't know which. So these are all done. This cannot be 3. This can't be 3, so this must be 9, which means in between has to be 30. So therefore this must be 6. So this is 6, which makes that 7, which makes this 6. This can't be 3 or 9, so this is 8, which means this can't be 8. This has to be a 4. This cannot be a sandwich, a bread. This cannot be a bread either because we have 2 breads in the column. So one of them, ones, is here. This is 2, 3. This has to be, what, 7 and 8? This is 4, 7, 8. So this one's done. This one's done. This one's done. This one's done. We just have this, this. Oh, this can't be 7. This is 4, 6, and 8. This can't be 8, though. This is 7. If this is 1, it could be there. Then that would be 2, 5 in between. Actually, it could, no, because it can't be 3 here, right? So you can't have 3, 4. So if this is 7 and that's 1, this could be 2, 5 to add up to 7. That works. If this is 3, actually, what's already outside? We already know it's at least 7 and 8, which is 15. Oh, so it's less than 20. That's what's in between then has to be less than 21 because it has to be at least 20 outside. Sorry, 15 outside. Actually, it is at least 20 outside, so then it's less than 15, which means this has to be a 1. So this is a 1, which makes this a 3, which makes that a 1. This is not a bread, but this is a bread. This is then not a bread, so this must be a bread. This again has to have 7 in between, but the 7 can't be there. So this must be 2 digits, and this is a 9, which means this can't be 9, which forces this to be a 9. So this is a bread, this is not a bread, this is not a bread, and these are not possibly breads, so this must be the last bread. So this is a 9. This has to be 2 and 5 in between to add up to 7. So this can't be 2, which makes that a 3, which makes that a 2. This 3 means that can't be 3, so this is a 6, which makes that a 3. This cannot be 6 because that multiplies to 54. If this is 4, this would have to be 6, which would make that multiply to 24. But 24 is not possible to be in 3 cells without a 9 or an 8. So this cannot be 4, so this has to be 7. And it cannot be 5 times 7, which would be, what would it be? 35, which is not possible to be in the sandwich, so it must be 2. So this must be 2, which makes that 5. This 2 means this has to be a 5, which makes that a 2. This must add up to 14. And if it's 5 and 6, that works with 3. But 4 and 5 does not work because it would have to have another 4. So this has to be 6 with 3, which makes this a 4. This can't be 6 anymore. This can't be 6. These can't be 7. So again, this 7 times 2 works. What about this? If this is 4, this becomes 8, and 32 is definitely not in between. So this cannot be 4. If this is 6, this would be 6 and 1, which is possible. It could be 2, 4. If it's 8, well, okay. One thing we know now is that this is a 6-8 pair, which eliminates 6 and 8 from the rest of the row. So this has to be 4 then. If it's 8 with anything, it would be 2, but the problem is 8 and 2 multiplied to 16, and 4 plus another digit is never getting to 16. So this has to be 6 and 1, which makes this 2, which makes this an 8. That makes this a 4. That makes this 8, and I think it's all just Sudoku now, because I think we've solved for all the outside clues. The square is 16, 2 times 8, and we have 16 in between. 7 plus 4 plus 5. This is 2 times 9, which is the same as 6 times 3, which is 18, and we have 18 in between, 3 plus 7 plus 8. This is 5 times 6, which is 30, and we do have 30 in between because we have 5 outside. This is 6 times 2, which is 12, and we have 12 in between, 7 and 5. This is 7 times 1, which is 7, and we have 7 in between. This is 7 times 3, which is 21, and we have 4 plus 6 plus 8, which is 18 plus 3 is 21. This is 7 times 2, which is 14, and we have 3, 6, 5 in between, which adds up to 14, and we have 6 times 1, which is 6. And that adds up to, and this cannot be 6, 7. This can't be 8. And yeah, we're probably just doing Sudoku now. Because, okay, so we have 5 times 1, which is a prime, which is 5, and 5 is in between. So that works. This is 9 times 3, which is 27, and we have 2 and 8, which adds up to 10, 4 and 6, which adds up to 10, and 7, which adds up to 27 as a total. So yeah, we're just doing Sudoku now. This then has to be a 7. This has to be a 6. The remaining digits here are 5 and 7. This can't be 5, so this is 7, which makes that 5. This 7 makes that an 8, which makes that a 7. The remaining digits here, well, the remaining digit here is specifically a 4. Remaining digits here are 3 and 5. This can't be 5, so this is 3, which makes that a 5. Remaining digits here are 2 and 6. This can't be 7, so this is 6, which makes that 7. This can't be 6, so this is 2, which makes that a 6. This 2 means this can't be 2, so this is 8 and 2. That leaves this as an 8 and this as a 4. And we solved the puzzle. Pretty cool, actually. I like that the logic flowed very well. Starting from the prime to the odd to the square, and then that flowed that way, down that way, because it had to match the other clue that was on the other end, which was really cool. That was actually really cool. Just that thought process was really nice. And then everything else was just filling things out with possibilities. Nice. I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.